1.36 volts is greater than minus 0.83. So we invert the minus 0.83. So it becomes plus 0.83 and then we add them together. So 1.36 plus 0.83 is 2.19 volts. So this becomes plus 2.19 volts. By using one of the phrases more positive, less positive, or no change, use the equations you wrote in A to deduce the effect of increasing Cl negative aqueous ions. I will not use my equations that I've written in A because sorry, I will not use the equations written in A because the electrons are on the right. So I will instead use the equations that I've written on my own over here. So I have to deduce the effect of increasing Cl negative aqueous ions on E anode production of O2. Now if you see in the O2 equation there is no Cl negative. So obviously a change in the concentration of Cl negative will not cause a change in the production of O2 because there is no Cl negative in the equation. So we cannot apply Le Chatelier's principle over there. However, in the second part, the E anode for the production of Cl2, now obviously Cl negative is in this equation. So as Cl negative will increase, the system will act to oppose this increase. So the equilibrium will shift to the left and this will make it less positive. This will make the E value less positive. So yes, we are done with this concept as well. Now let's move forward. Predicting the products of electrolysis of aqueous solutions using E0 values. Now in this case, for example, let's say we have done molten electrolysis, but now we are doing electrolysis of aqueous solutions. As I said, we would do it later, and now it's that later time when we are doing it. So this is now we come back to a basic electrolysis. So these are graphite electrodes. This is the cell and this is the electrolyte. Now earlier we used molten NaCl, but this time we are using aqueous NaCl. So this will be Na plus aqueous and Cl negative aqueous. So this time we are using aqueous NaCl, but so in aqueous NaCl we also need to know that there will be H plus ions and there will be OH negative ions because water molecules will also dissociate. Water molecules also dissociate to form H plus ions and OH negative ions. So we will have these. Now the cathode, we know that this is the cathode. Let's write cat and let's write an for anode. Now we know at the cathode either H plus ions can go and accept electrons or Na plus ions can go and accept electrons. So Na plus E negative would give us Na. H plus, so we have to do 2H plus 2E negative will give us H2. So which one will go to the electrode? Will H plus go and discharge at the electrode or will Na plus go and discharge at the electrode? I mean cathode specifically because they will discharge at the cathode. Positive ions go to the cathode. So if we look at the E0 values for these two equations, for sodium it is minus 2.71 volts, and for the H plus equation we know it is 0 volts. So if you see, hydrogen H plus ions have a stronger drive to form H2 than sodium ions have to form Na, because this negative value means that this change from sodium ions to sodium is not feasible, and since the change from H plus to H2 is more positive than the change from Na plus to Na, this reaction is more feasible. So instead of Na plus ions, H plus ions will move to the solution and H2 gas will be formed. So when we had molten NaCl, sodium metal was being formed at the cathode, but when we have aqueous NaCl, then hydrogen gas is being formed at the cathode. Now, for the anode,